Hi, I'm Jacob.
And I'm James. So this is our Michelson interferometer. Light is going to enter the system through here. Similarly, it's going to on-axis ray. The ray is going to go through the beam splitter, be split into two beams. One is going to travel through the beam splitter again, reflect off this mirror here, and travel through the beam splitter once more for a total of 3 times through the beam splitter. The second ray is going to travel through the commutating plate, reflect off this mirror here, through the commutating plate again, and reflect off the beam splitter to join the second ray. The compensating plate therefore ensures that the optical path length for both rays is the same. So the first effect we saw with our Michelson interferometer was Haydn's fringes, often known as fringes of equal inclination. So if you look at our diagram here, we see these two lines, A2, B2, A1, B1. These lines represent images of the extended source created by our interferometer, specifically the beam splitter. These lines here represent fringe lines, and it is fringe lines of equal inclination that correspond to a single ring here, since these fringe lines are distributed radially. It should be noted that these fringe lines are localized at infinity.
Part of the experiment, we did the fringes of equal thickness, or the straight fringes. This was accomplished by making the OPD 0, which means that the mirrors were the same distance from the beam splitter. However, we tilted one of the mirrors so that the images would look like this. And as you can see, as these two sources interfere, they're going to create straighter and straighter lines right here, which we would see as this over here. It's also important to note that the fringes are localized at the mirrors. This is our white light fringes experiment, or the last part of the experiment, and this has to do with this can only be used with the fringes of equal thickness because the OPD must be equal to 0, which cannot happen with the other fringes. The reason the OPD must be 0 is because as you can see by this diagram here, if the OPD isn't 0, then the light starts to not line up, and that means that it will just look like white light and you won't be able to see the difference in the lights. This is a picture of the one that we got in the lab. Okay, so for both the circular fringes and the straight line fringes, when you increase the OPD, you increase the distance between the fringes and the pattern. And to do that, you go from smaller to larger on the micrometer.